Swift file. And since our model is completely UI independent, it doesn't subclass any iOS class or anything. It's just a basic Swift file. So I'm going to pick on this Swift file, click Next. And now it wants to know the name of it and where we want to put it. And we're going to put it in the same place that all our other Swift files are. Here's our controller. And this app delegate, we moved it out of the way at the very beginning of the very first lecture, but it's in there too. So we want to put it in this same directory. And we're going to call this new class Calculator Brain. Now, you don't have to have the name of the Swift file here be the name of the primary class, but we always do that. It would be kind of confusing to people a little bit if the name of the Swift file was different than whatever the primary class is in there. But it's certainly legal, all right? In Swift, the name of the file really doesn't mean anything. It's what's inside that matters. But Calculator Brain is going to be the name of our class, our model. I'm calling it that because it's the brain of our calculator. I'm trying to pick a descriptive name. Notice the capitalization here. Types in Swift, we always capitalize them. And we do not put underbars and other stuff in there. Okay, we use what's called this camel notation here, where every word gets capitalized, including the first name word for types. Everything else, we don't capitalize. So property names and things like that, function names, those always start with lowercase. They still do the uppercase of the other words. That way, in reading our code, we can really quickly pick out what's a type and what's not. Okay, so please adhere to that. If you don't, you're going to look like a noob out there. Okay, Calculator Brain is what we're going to call it. I'm going to create it. Here it is right here. I'm going to make it my whole screen. You can see that the import here is not import UI kit, it's import foundation. Foundation is that layer, that kind of core services layer I talked about in the first lecture. It doesn't have any UI stuff in it, which is good because our model is UI independent. So there should be no UI in here. So we would never be importing UI kit into a model class. Okay? And feel free to stop me, by the way, if you have any questions. All right, so we're going to create a new class. You already know how to do that. We just type class, and then the name of the class is going to be Calculator Brain. Now, this class is not going to inherit from any other class. Okay? It's just going to be a basic Swift class. Now, sometimes your model might inherit from a class called NSObject, and I'll talk about that a little later, maybe on Wednesday even. You'll get a little bit if you inherit from NSObject, but we're just going to have it be a basic Swift base class. Okay? It doesn't need to inherit any functionality. Okay, so what's going to be our data structure of our calculator brain? It has to be a little different than the data structure we used in our controller to capture the operands, because we've got to capture operations and operands both into this. So we want it to be a stack. I'm going to call it op stack. But the type can't be array of double, okay? Because operands are doubles, but operations are like a combination of a mathematical symbol, like plus or times, and then also a function that actually does the thing, okay? So obviously we can't do that. So we're going to have to need some new data structure. I'm going to call that data structure op, and we're going to define that in a second. So op is going to be something that could be an operand, or maybe it could be an operation. Okay? It could be either or. Okay? Now, a couple of things about this here is, of course, I have to initialize this, so I'm going to do the exact same thing that I did in the controller, which is I'm just going to create an empty array of op. Okay? And I'm even going to use a little different syntax. Okay? We've been using this. I like this syntax because, especially for people who are first time to Swift, it's very clear this is an array, and inside the array are these ops. But this is evidently not the syntax that is preferred. The preferred syntax is actually to do square bracket op. Okay? So this is just an alternate syntax, putting square brackets with the type in the middle, for declaring an array. It's exactly the same thing. Just a different way of typing it in, identical in every possible way. It's exactly the same. Okay? I think this is a little bit preferred because if you ever initialize an array, which we'll see later, you use this syntax to create the array and put things in it. So I can understand why they do that. Okay? So this is an array of op. That makes sense? Now, let's talk about op. What kind of thing should op be? Well, we could make op a class, and op could have a property for an operand, which would be the value of the operand. It could have another property, which is the symbol, mathematical symbol for the operation, and another property, which was a function, which does it. And obviously, if the operand is set, then the other two would be not set, and vice versa. But that's a little bit weird to have a class that has properties that sometimes are set, and if other things are set, they're not set. It's really not what we want. What you really want is an enum. Okay, so you're probably used to enums in other languages, so I'm going to create an enum. It looks very similar to creating a class. I just used the word enum instead of class. Obviously, no inheritance for enums, sorry. But enums can have functions, just like a class. They can also have properties, but only computed properties. Okay, they can't have any stored properties. So, you know, enums are kind of for basic types, and enums are really great when you have something that can be one thing one time and a different thing another time, and never both at the same time. That's kind of what enums are, right? They're enumerating different possibilities. So we could say, you know, case operand, and we could have a case operation to have the different things that we have. Now, in other languages, this would be as far as we can go, and this would be pretty useless, because if we had an array that just said whether it was an operand or an operation, that doesn't help. I need the actual operand. I need the operation's mathematical symbol and its function. I need them. They have to be in this enum. And Swift has a really cool feature where you can associate data with any of the cases in the enum. So for an operand, I'm going to associate the data double. So if my enum is an operand, it'll have this double associated with it. That's going to be the value of the operand. And similarly for operation, I'm actually going to do unary operation first. That's a single argument operation. I'm going to have a string, which is going to be the symbol, the mathematical symbol for it. And of course, I'm going to have a function. Okay? Again, functions are just types in Swift. It's no different than string. Okay? We're just saying this is a function. We put a function in there. A lot of times we'll do the curly braces and put a closure, use closures to create our function, but we could create actual functions and pass them in there. It's fine. So, and we'd also want a binary function here too that takes 2 arguments. Binary operation, and just has 2 arguments here in its function. Okay, so now we have a stack, okay, which is an array of ops, and these ops are each op in this array is either an operand or it's one of these 2 kinds of operation. Okay, so so this is great. We got this op. It's either an operation or an operand. How are we going to, you know, put things into this op stack, for example, and stuff like that? So let's go talk about the API. API stands for Application Programming Interface. API is kind of all the methods and properties that make up your class, the description of them. So I can use that word a lot, API. And we really need to be able to put an operand on there in the stack, and we need to be able to put an operation on. So I'm going to have a function called push operand, and it's going to take an operand, which is a double. Okay, it's not going to return anything yet, anyway. And to push an operand on my stack could not be easier. I'm just going to say op stack append. You'll remember that append is a function in array, and the thing that you put on obviously has to be this little type T. T is whatever you put in here, so op in this case. So we obviously have to have an op here. How do you create an enum item? You just say op dot operand, and you give it the associated value. Okay? So very simple kind of way to create these enums and associate the value with them. Any questions about that? Okay, and then how about operations? We'll have, instead of push, we're going to call this perform operation. And I think when I do perform operation, what I'm going to have is my calculator brain is going to have a bunch of known operations, things it knows how to do. And when you perform an operation, you just specify the mathematical symbol of it. So the argument here is going to be symbol, which is a string. Okay, so to append an op on here that it's an operation, I'm going to need to have these known operations. So how am I going to do that? Well, to have known operations, I'm going to create another instance variable here called known ops. It's my known operations. And it's going to be a dictionary. Okay, now you read about dictionaries in last week's reading assignment. That's why I have the reading assignment due today, because then I can know you've read about them. I hope you have. And so how do I create a dictionary? It looks like this, dictionary. And it's the same kind of thing with these angle brackets, because you have to say for the dictionary what type are the keys, what type are the values. And our dictionary is going to have keys that are strings, and it's going to have values that are ops. Oops, sorry, ops. Okay? And I'm going to create one. Okay? Everyone understand this? Now, this known ops, I'm just going to put all of the ops that I know in there, where the key is the symbol and the value is the actual op. And then when someone says perform operation, I'm going to look it up in the known ops. And when I find it, then that's the operation I'm going to push onto the stack. Right? Makes sense? But I have to load this known ops up. Oh, well, first of all, so let me talk about this syntax. Just like array has a special syntax with the square brackets, so does dictionary. So to have a dictionary like this with this kind of special syntax, we're going to do open square bracket and then a colon in between the key and the value type. So it looks like that. So it looks very similar to array, but you've got this thing where you've got the key and the value separated by a colon. Okay? Same thing though, exact same thing. Just a dictionary, strings, looking up in strings to find ops. All right, so how am I going to initialize this known ops? Well, this is a great time for the first time for you to see an initializer. Okay? So far we've been creating classes, like right here, okay, just by putting these parentheses, and I told you that was calling an initializer in dictionary, okay, and this one was calling an initializer in array. And so we're going to have our own initializer in calculator brain, and we just do that by saying init, like this. Okay. Now anytime someone says something like let brain equal calculator brain with the parentheses, okay, it's going to call an init that matches the same arguments. In this case, no arguments, so it's going to call this init. Okay. Couldn't be simpler there. So what are we going to do in this init? We're just going to initialize this known ops. I'm just going to start putting some known ops into this known ops dictionary. We need our friend special characters here for that. So let's go ahead and put let's put times here first, I guess. Okay, and we need to create an operation. How do we create an operation? Very similar to how we created this enum, op dot. And times is a binary operation. And you can see it's typing this for me. I'm just pressing tab to get along. This is the symbol, which is this thing here. Now, it's kind of bad code that I ended up typing this twice in the same line. If I accidentally use the wrong X, like some X from somewhere else, or the X just from my keyboard might be different from this X, then this X, we could get in trouble where these things don't match up. So later, right at the very end of the demo, I'm going to show you how we could do this in a way where we don't have to type this X twice like that. Okay? But now we just need the function. We know how to do that with closures. I say $0 times $1 and the closure. And yes, I could put this closure outside since it's the last thing here. That is also legal to do when you're creating the operations like this. Okay? So that's kind of nice. Let's do our other 3 binary operations here. We'll go divide. And this is where it really gets annoying to have to type it twice, but I have to show you something else before I can show you how to do that right. Let's go here, and then we have minus. You can see there's 2 different minuses there, so hopefully I click the same minus in both those spots. And then we change these things. We know that divide is 1 divided by $0, and this is plus, and this is 1 minus 0, $1 minus 90. Okay? So everyone cool here? These enums are really easy to create. The API of them is really, really nice, simple. And then we have our other operation, which is our unary operation, which is square root. So let's put that in here. Square root is right here. And we'll put it right here. And square root is not a binary operation. It's a unary operation. Oops. Get all this. Okay. And of course, inside here it's square root of $0. Okay, you remember that from last time. So this is good. Now, while I'm here, I want to show you a couple things more about closures. Okay, what is this curly brace? It's a function that takes one argument and returns one argument. And we know that it's doubles because we're creating a unary operation, and so it's inferring the type here, right? Everyone understand that? Well, there's another function that returns a function, or so there's another function that takes a double and returns a double that does square root. It's called square root. So inside here, we could just say square root. Okay? We don't even need this business. Just want to emphasize that we're just passing a function here, and it can be a named function, or we could use these curly braces. Now, this is really going to freak you out, because watch this. For times, there's a function that does times called times. Okay? So in Swift, all these operators, times and all these things, are just functions. They just happen to be specified in a way that says they can infix, right, between the two arguments instead of taking the arguments in parentheses. And we do the same thing here with plus. Right? Plus. Now, we can't do it with divide and minus because the order is backwards. Right? We put the things on the stack, we put them out, pull them out backwards. So we can't do it with those. But I just want to emphasize that that's what's going on there. Okay, so now we have this nice known op. So we have this thing, it's loaded up. It gets loaded up whenever the calculator brain gets created. So that's all good. Now we can use that down here in perform operation. All right, so how are we going to use this in perform operation? Well, we basically want to let the operation equal known ops sub symbol. Okay, someone passed us a symbol. They're trying to perform this operation. So this is either a plus or times, hopefully an operation we know. And we're going to look it up in known ops. And the way we do that is with this subscript notation with the square brackets. Okay, that's how you look something up in a dictionary. But what might be kind of surprising to you, what type do you think this would be, operation? Any guesses? Yeah, some people are saying the right thing. You'd think this might be an op, because I'm looking up in known ops right here, a string. And so hopefully I'm getting an op. But this is not an op. This actually is an optional op. Okay, now why is that an optional op? Because you might be looking up something that's not in there. And it has to return, oh, nil. Sorry, couldn't find it. So that's why it has to be an optional is returned. So dictionary, whenever you look up something in a dictionary, it always returns an optional. Okay, either nil or the type of thing you said was supposed to be in there. So I'm going to if let here. I'm going to say if I'm able to look up my operation in my known ops, then I'm going to push it onto my op stack. Okay? Everybody cool with that? Make sense? Okay. Now, what's next? Well, now we have, I'm going to take a pause here to talk a little bit about access control. Okay? Access control is about public and private. Okay? What methods in this class are public? In other words, other people can use them. Other classes in my code are allowed to call them. And what things are private? My internal data structures that I don't want people messing with. Okay? So the way public-private works in Swift is kind of interesting. You basically specify the things you want to be private by putting the word private on them. If you don't put any word on them, then they're public inside your program. Okay? And you only use the word public if you're shipping out like a framework of objects to other people, and you want stuff in there to be public outside the framework. So I'm making some framework, a bunch of objects that I'm trying to sell to people or to get people to use to do something. And of course, I'm going to have things where my objects inside my framework can talk to each other. There's no keyword needed for that. Then I'll have things inside certain objects that are private, only to that object. I'll say private. And then some of them might be public that the customer who's buying my objects, my framework, can use. Now in this class, we're not going to be doing frameworks. We don't really have time to get to that. So we're not going to be using the keyword public. We will never use that because we don't have any frameworks. But we are going to use private. And starting with assignment 2, it's one of your evaluation criteria is going to be make private things private. Okay? So that is important to do. And you could just say, well, I like everything to be public. Well, that's bad. Okay? If you make your internal structure public and some other object in your program starts mucking with it and breaks your object, and then you come to a new version of your program and you change something and now everybody's breaking, that's bad, okay? That's chaos. So the only things that want to be not private are things that you're committing to sign up to support. So in this class, the only public things so far are the initializer. Obviously, we want to allow people to create a calculator brain. That's clearly public. Also, pushing and performing operands and operations, that's public. Okay? Everything else, for now, I'm going to make private. So I'm going to make this private. Notice that if I make this private, it's going to start saying, whoa, wait a second. This can't be public. You know, it can't be non-private because this is private and it uses it. That's what this warning is going to say right here. See, property must be declared private because its type is private. Okay, this type this. But I want this to be private anyway. This is my internal data structure, op stack. Now, known ops is kind of an interesting one. Maybe I would want that to be public one day because maybe I want people to use my calculator brain and teach it new ops. That wouldn't be that unreasonable. However, I'm not ready to support that functionality in my calculator brain. I'm just not sure I want to do it this way. Maybe I don't want this property to be public. I might want to have some functions to learn an op or something like that. So I'm just not sure. So I'm going to start out private. And that's really, when you're designing APIs, you want to kind of start out, make it private first, and then open it up as you're willing to support that functionality. Question?
Is the common view in Swift to make most instance variables private and use getters and setters, or is it to make them, if they are supposed to be public, or make them public and then let the...
All right, so the question is it kind of part of the Swift way to make most instance variables private and then have getters and setters that are public to get them? That doesn't really even make sense in Swift. That's more of an Objective-C thing. In Objective-C, you had instance variables, and then you had properties that would get and set them. In Swift, it's kind of merged those a little bit closer together. So that properties are really kind of the public or private getters and setters. So if you have a property, you just have to decide whether you want people to access it or not. And if not, make it private. And if so, make it public. And that, you know, don't make it non-private, basically. And that's all you need to think about. I wouldn't even think in Swift in terms of instance variable versus the property. Now, it is still possible in Swift to do that because you have computed properties. And those could be setters and getters that are setting private properties. But we're going to see on Wednesday even, I'm going to talk to you a little bit about a way that when your properties get set, you can intervene. You can check them to make sure the value is okay. So if you have a public property, you can still protect it by intervening a little bit when people set it or try and get it. So it is possible to still have some protection there. We'll see that. All right, so these are our only public things. Now, there's only one other public thing we need to do in our calculator brain, which is we need to let people evaluate this stack. So people are pushing operands and performing operations. Now they want to know what's the result. Okay? They pushed an operand of a 5. They pushed an operand of a 4. They performed operation plus. They want to see 4 plus 5. Where's that 9? Okay? They need the result. So we need another public method here, which I'm going to call evaluate. Okay? And evaluate could have it return a double, for example, and it would just evaluate this op stack and return the value. But I really can't make this a double. Really, this has to be an optional. Okay, why does this have to be an optional? Well, that's because someone might get my calculator brain, and the first thing they do is they say, perform operation plus. Okay, well, I have no operands, okay, and you're asking me to evaluate plus. I can't do that. So I have to return something to you that lets you know I could not evaluate what you asked me to evaluate, so I'm going to return nil in that case. So evaluate here really needs to be an optional. Okay, so you can see some of the thinking. When do you make something an optional, when not? Okay, so this is a classic case of that, where you've got sometimes you want to return it, and you can't do it, so you have to return nil. All right, so how are we going to implement evaluate? Okay, how many people in this class, raise your hands, don't be shy, are you comfortable with the computer science concept of recursion? Okay, excellent. That's about 80 or 90%. So I'm going to explain this really fast then, And if you don't understand recursion, if you didn't raise your hand, that's something you should go review, okay? Recursion is something you should know by the time you take this class, so that's something you definitely want to know. So how are we going to use recursion to evaluate this stack, all right? Looks like this. I'm going to do a sample stack right here. So let's say I put a 6 on the stack, and then I put a 5, then I put a plus, then I put a 4, then I put times. Okay, so here's our stack, and I'm going to evaluate this, and I'm going to use recursion. How am I going to do that? Well, really, what I'm going to do is I'm going to have a helper method here, a recursive helper method. I'm going to call it evaluate also, actually. And it's going to take a stack as an argument, a stack of things to evaluate, and it's only going to evaluate the top thing on the stack. That's it. It's just going to evaluate the top thing on the stack and return it. But the top thing on the stack might involve looking at every single one of these, right? Because this times needs its 2 operations. So let's look at this. This recursive evaluate is going to come in here. It's going to try and evaluate the top of the stack, which is a times. Okay, so it's like, okay, I'm doing times. Now, for times, it needs two operands here for times. So it recursively calls itself to say, give me the first operand for times. And so recursively comes in here. It finds a 4 on the top. It's like, I know how to evaluate 4. It's 4. So it just returns. Okay? So now I have my first operand. Okay? Now I take the rest of the stack and evaluate it to get the second one. And when I do that, I get plus. Okay? So plus says, oh, I have to evaluate plus. It needs operands. So I come over here. I'm getting a plus. And I got to go recursive again to go get its operands. I get the 5. That's good. I'm going to go recursive again, get the 6 over here, and I've evaluated the whole stack. So you see how I have to keep going back recursively to my evaluate to get the operands for my operations. Once I get to an operand, I can stop. Okay, as a number, I got it, and I'm out of there. But every time I encounter another operation, I have to keep going recursively to get all my arguments. Any questions about that? Okay, so it's actually going to be pretty simple recursion. When you see the code, you're going to be, oh, yeah, that makes sense. So I'm going to have this separate, I'm going to put this up on top for scrolling reasons. Oops, didn't mean that. A separate evaluate. And this evaluate is going to take a stack of ops as its argument. And why does it take a stack of ops? Because as it's recursing, it's using the rest of the ops. So you see what I mean? It can't be looking at the big op stack in our brain. It can't look at this, okay, because it's kind of consuming it, right? And every time I call it recursively, I'm giving it fewer operands to work with. So this is what I'm doing. Now, the first time I call it, right here, I'm going to give it the full op stack. So I'll call my recursive one from here. Now, what's this thing going to return? Okay, that's interesting. And here's a big new thing for you to see. You've read about it. I can't remember even I actually did read about this, but I think I guess I didn't, which is tuples. Okay, so in Swift, you can combine multiple things together into one kind of really mini data structure called a tuple. Okay, don't let the 2 sound in there fool you. It's not just 2, it's any number. Okay, and you just put them in a parentheses. Okay, and that's it. So you can use this for return values. So I've got a function right here, and I actually need to return 2 things from this evaluate. Okay, one thing I need to return is the result of evaluating it. But the other thing I need to return is the rest of the stack that I didn't use. Because as I'm working my way down here, and I take off that times, and the 4 and the 5, okay, I'm consuming things, but then I'm leaving the rest of the stack. So I have to keep returning what's left of the stack so I can keep consuming it. Okay? So I'm going to return this in a tuple. Tuples could not be simpler syntax, just open parentheses, not 9, open parentheses, and then just all the types of things you want in here. So I'm going to return a double question mark. That's my result. Okay? That's what's eventually going to be returned out here after all the recursion unwinds. And then also, I'm going to have the ops that are left over. Now, a tuple can look just like this, unnamed. You see how these things are not named, each of these things in here? But you can also put names in here if you want as well. So maybe I would call this one the result, okay? And I would call this one remaining ops. Okay? And I kind of recommend putting those in there, and you'll see why in a second, because there's two ways to call a function that returns a tuple and get the results. And one of the ways requires that you name these. Okay?